Hello, everybody, and welcome. I'm so glad you're here. My name is Kelsey Derringer, and I am the Professional Development Coordinator for BirdBrain Technologies. So that means that I get to work with teachers all over the country to help them bring robotics and computer science into the classroom, and I also get to work with students like I'm going to do today. But it's not just me here in the studio today. As always, we have Matt, the robot. Hey, Matt. Whoops.
Hey, Kelsey. How you doing today?
I'm doing great. How are you doing today, Matt?
I'm doing well. I'm excited to answer some of the questions that will be coming in from Facebook.
That's right. So Matt is our director and producer, and he is monitoring our Facebook Live video. So if you are watching us live on Facebook, you can leave a comment, whether you've got a question or you've got something you want to add, a story you want to tell, or even if you just want to say hey, or give some positivity to some of our learners today, you can comment live on Facebook and we will see that and bring it into the class in real time. Yeah, that's right. But it's not just me and it's not just Matt. We have a whole Zoom meeting full of folks today. Do you guys want to wave hello if you are on the Zoom call? Hello. So these folks are going to be doing our programming today. It's not me that's going to do the programming. It is you guys who are going to do the programming. And what are we going to be programming today? Well, we are going to be programming robot parade floats like this. So let me turn this guy on here and show you how it works. We've made it in two parts so that it's easy for us to program a couple different things happening. So this parade float, does anybody want to unmute and say what they think this parade float is? Is it a school lesson? Is it a soccer game? What's happening on this parade float? What do you think, Penelope? Do you want to unmute and tell us, what's this parade float doing? What is this?
That's a good one.
What is it? Can you tell? There's a merry-go-round, there's a swing. What do you call this thing?
There's a swing, a merry-go-round, and a seesaw.
And a seesaw, that's right. This is a playground. So this is a robot parade float that, when it's working, is a moving playground that can parade down the street. Now, we did not come up with this idea for a robot parade float playground. This actually came from a teacher in the Penn Manor School District, and I actually have a tweet that I sent out with the original video that I want to show you guys. So here is our robot, the original robot parade that I did with, I guess this wasn't the first one that I did, and it wasn't the first one that anybody from BirdBrain did, but you can see this is the original playground design that someone made. So you can see this robot parade float is made out of a cereal box, and the theme for what all the parade floats were supposed to be was the power of hope. So you can see these nice hands here. What you can't see, because I did a bad job filming, is there's the world above them. The hands are holding the world in them. This one coming up here, it's really hard to make them go straight, is the fun fact. This one was the light at the end of the tunnel. So you can see there's someone holding a light at the end of a tunnel. And this one was some hopeful things coming out of a box here. There's peace and love, and there was a dove and things like that. So I've done this, this as a professional development with teachers, this project, a few times before, and we really liked that playground one as something that students could edit and could control. And that's what you guys are going to get to do today. So let me show you the other cool thing about this parade float. I'm going to turn it on here, and then I'm also going to turn the bottom part of it on, and then we're going to head over to the studio, because this parade float is going to parade on an actual parade route. So in just a second, you'll see it come on screen there. Check this out. This parade float is also a line following rover. So it's got a light sensor and an LED kind of sticking out the front there. And it's following that black electrical tape, or black gaff tape, whichever that is. And it's following it on our little parade route there through our carnival with cheering crowds. Do you remember crowds? That was cool when there were crowds. But this parade float, if I come back to the front here, I'm actually going to go to my close-up. This parade float on the bottom, it's got a little light sensor and an LED. And when I cover up the light sensor, I guess when I cover it, sometimes one wheel goes, sometimes the other wheel goes, depending on how much light gets into the sensor there.
If you make it dark, that other wheel will start to turn.
Make it really dark, like that. Cover it up.
Oh, maybe that is the dark.
I
Oh,
think
that's
that is
right.
the dark. If I shine the light back at it, it'll go. Well, we'll investigate the coding of the bottom part a little bit later. But we're going to start with this top part here. We're going to investigate these things that are moving back and forth on here. And there's lots of ways when you're using different components on a Hummingbird project, there's lots of ways to get those all to work at the same time. So we've got a seesaw, like Penelope pointed out, that's moving. We've got a swing that's going at its own speed. And we've got a merry-go-round as well. So we've got 3 motors that are all working at the same time. And what I'm going to do now for the folks on Zoom who have joined our microbit classroom, ooh, this is loud. I'm going to share the code with you that's running this robot right now. And then we're going to investigate it. So make sure you share it with not the other 2 Kelseys if you can. Okay. Just that one. And you'll go back to the original one to share it
Yes.
here. All right. So, and for those teachers who are interested in how we do this, we'll kind of show you off to the side here. I've pre-made some code. I called it AA Kelsey 1. This is the first one I'll be sharing with you. And we're going to share that code with all the students except for my other 2 accounts that I made because I have other code I want to share with you there. And so now we're going to send that code to everybody. So let's go to gallery view. Everybody give me a thumbs up if you just received some code from your teacher. Did you guys just get some code from me? Okay, wonderful. If you haven't joined our microbit classroom yet, we've put that information in the chat on Zoom so that you can open that up. So now we can investigate what that code is doing. And if you're having any troubles joining our microbit classroom, please unmute yourself or raise your hand and let me know because it's really important that you can join that, okay? Is anybody having any trouble? Do you need some help getting on? Okay, all right, let's go back to speaker view because I want to show you the code that I have made. All right, so here's the code that I've made here that you guys now get to edit. So I'm gonna take that out so we have a little more space to see what we've done here. I've got 3 separate forever loops. And I think this is something that's really cool about block-based programming, that you can make separate forever loops to kind of keep things organized. So this one, Hummingbird Position Servo 1, that is controlling the swing back here. That's Hummingbird Position Servo 1. So that's going back and forth to a couple different angles at 130 and 70. And it's waiting for a second in between, and I'll let Matt share that code. I know you need to do that. So it's got 3 different motors that are built onto it here. Hummingbird Position Servo 1 is the swing, and that's going back between 130 degrees, I think, is back here, and 70 degrees is up here. It's waiting a second in between. And then the second Position Servo 2, is the seesaw, and that's also going between 130 and 70 degrees. That happened to work out, but it's waiting every 2 seconds. If I turn it back on, you can see that one's waiting every 2 seconds in between when it moves. So this one's going every 1 second, and that one's going every 2 seconds, so it's a little slower. And then Hummingbird Rotation Servo 3 right here is set to 35% speed. So it's not going full speed. It's going 35% of the full speed that it can go. I'll show it to you from the top here as well. So motor 1, motor 2, and motor 3. And what I'd like you guys to do is I would like you to edit that code. Change some things in there. Change some of the angles. Change the pause value. So the pause blocks in there are how long it's going to wait at each of those positions. Add some more angles or add some more speeds or make it spin the other way if you'd like to. So take a couple minutes to edit that code that's shared with you. And if I see there's a couple folks on Zoom who say that they haven't gotten the code shared with them yet, it's because it's shared with you through Microbit Classroom, and we'll share that information in the chat again so that you can join. Remember, you go to microbit.org/join, and then it'll ask you for a color. And I saw somebody said like, oh, purple wasn't an option. You may have to scroll down to find more options for like purple was our color. You'll enter in that information and then you'll get there. Wonderful. So while you guys are coding and programming, this is all about parades. So I want to give you guys a couple minutes to do that. And I know that some of us have been to parades before. Does anybody want to share about a parade that you've been to in the past? You can raise your hand if you want to tell us about a parade, like a 4th of July parade or a St. Patty's Day parade. Does anybody have one that they've been to that they want to tell us about? If I can call on Ruth, because Ruth and I are pals. So Ruth, do you want to unmute? You said you've been to the Rose Bowl parade. What's that like? Will you tell us about it?
I have been to the Rose Parade in Pasadena. It is amazing. It's beautiful, the floats, but it was amazing to go this year after kind of like investigating BirdBrain, because then while I was watching the floats, I was thinking about like, oh, how are they doing that? How are they making all those things move? So it's amazing. They're beautiful floats. Lots of people.
I think that that's really true. Once you start to learn a little bit about coding and robotics, you walk around the world a little bit differently and you're like, that's moving. Is that a position servo or a rotation servo?
Yes.
The door sensed me when I walked up to it. Is it a distance sensor or a light sensor or a motion sensor? Like you just start to see the world a little bit differently. And the cool thing about the Rose Parade, I think, is that all of the floats, all of the parade floats there are not covered in paper. They're covered in organic materials, so like rose petals or seed shavings, things like that. Plus, all of them had, they all have a theme. Like each year, the Rose Parade has a theme. So this past year, the theme was the power of hope. And we didn't quite know how much we would need that theme, I think, when we started 2020, but here we are.
Completely. Yeah, we got to walk around and look at the floats up close. You can go afterwards and walk right by them, which is neat to do too.
You can really see how everything is put together. All right, so let me go to gallery view in just a moment here, and I want to see. Does anybody want to raise their hand? Do you have some code that you want to put on our robot parade float here? Did you change something? Looks like Kat and Elise have some. Let's do Kat and Elise's. All right, I'm going to plug it in, Kat and Elise, and we're going to share your code with Kelsey Student 1. And no, not that one. This one. Because we did something fancy and we used 2 different hummingbirds on this project. So Kat and Elise, will you guys unmute and tell us, what did you change about the code for our robot parade float? What are some things you changed?
Faster. Kat wanted everything, most of it, to go faster.
Oh, all right.
Oh.
Let's get wild, Kat. Let's see what you did. All right. So Kat, we have your code here and we're gonna go ahead and download it. And then we're gonna take a look at it too. All right. And can you see it blinking right there? That means it's downloading. That lasts for about 5 seconds. And then we'll get a little happy face. Happy face? All right, here's your code, Kat. Oh, hey, look, that swing is moving a lot faster now. That's great. Let's see what you did with your code. We'll put it here so you can still see the parade float and you can see the code. So look at that. You changed the amount of time it's waiting for that swing. So it's going a lot faster, right? What did you change here to make this go faster? What did you change for the position servo 2 to make it go faster, Kat?
Remember what you changed on the second one. And this one, we changed the seconds too, right? So
Yeah.
she changed the time and the angles or whatever's the
Yeah. So in this one, you changed in the second one here, you changed the time. Oh, and in the first one, you changed the angles too. So it's actually swinging back a little further because going all the way to 180 degrees. Cool. And then the third one, you made it instead of 35% speed, now it's 55% speed. So it's going a little faster. Not fast enough yet where the kids will get flung off the merry-go-round. So good job. Not a dangerous merry-go-round, which is great. And it looked like we had a couple other people who wanted to try putting their code on it too. Will you guys raise your hand? If you have a code, do you want to try yours, Nihal? All right, Nihal, do you want to unmute? We're going to find your code and share it with ourselves. And tell us what you changed, Nihal. How's it been?
I changed the for the merry-go-round, I made it use like all of its, I think, like power. So I think it's gonna go really fast.
You're just going to bring those kids across the playground. That's great.
And I think for the swing, I changed the angles to 35 degrees and 180 degrees.
Okay. Well, we're going to download it and see what your code looks like. All right. It's blinking. Do you see it blinking? That means it's downloading. It takes about 5 seconds to download. Here we go. Once we get a happy face. Ta-da! And we're going to see what it does. Those kids are really moving now, man. Oh, man. Our teeter-totters, they're kind of going into the ground. They're really pumping. What do you think, Nihal? Do you like this code that you built?
The seesaw was a bit more than I thought it would go.
Went a little further. Well, that's actually something that we built this playground to be able to do. We built it to make it so that you can't break it. It might look silly, but you can't break it. So let's take a look at this from the top too, because something that I think is cool is being able to see this swing, so that you can see that it's like staying up in the front longer than it's going back here. And I want to look at your code to figure out why it's doing that. I think that's an interesting interaction. Oh, and here we can see, because it's only staying back at 130 degrees for 200 milliseconds, and it's staying front at 70 degrees for 1,000 milliseconds. That's why it's moving it's staying there for different lengths of time. Does that make sense, Nihal?
Yeah.
Cool. Nice coding, man. I like it. Pretty cool. So I'm going to turn this off for just a second, because that's not the only way that you can code something. By using, I think especially when you're first starting out coding, using separate forever loops like this. I'll unplug that so it stops moving. Stop. There we go. Using separate forever loops can be really handy. It's an example of a habit of mind that some people call decomposition, which is like taking a big problem, I want everything on here to move, and breaking it into some smaller problems. And then once you've solved each one of those smaller problems, you solve the big problem, right? So the process of breaking your code apart into some different forever loops so that each forever loop just controls one component is a good way to kind of break those things apart and keep them organized in your head when you're just starting. But it's not the only way to code and program something. I'm going to show you another way in just a moment, but it looks like we have a couple comments and questions coming in. What's up, Matt?
That's right. We've got a couple comments on Facebook. Nick says, hi, interesting. And he went to a parade of flowers in New Jersey many years ago and had a fantastic experience. So glad you had fun. And Sonali said that she signed up for a Zoom class but did not get the email. Hopefully you were able to get some of those sign-in credentials. Please let us know in the chat if you're still having trouble signing in.
Yes. If anybody would like to sign up for future BirdBrain webinars, we're going to be doing student-focused and teacher-focused webinars every week for the next few weeks at least, and then again come fall. So definitely we'll tell you our website so you can check that out in just a little bit. But I want to now program our robot to work a little bit differently. I'm going to plug this back in. And I want to check out some other code that we built here. So this code has all the same things going on. I'm going to zoom out just a little bit, get rid of that. This code has a lot of the same thing, has all the same components working for it, but I put them all into one long forever loop. So there's rotation servo 3, there's position servo 1 and 2 and 2, and we're going to share this code with you. And I want, and we're gonna download it. Let's do this, Matt. We'll download it onto this robot here, and then we'll share it with everybody so that you can see what this version of the code looks like. We just downloaded it. I'll go here so you can see it's like blinking away. There it is, blinking. After about 5 seconds, I'll turn it on. Here we go. So we can see that this is working a little bit differently. It's a little more sort of stunted because of the pause block. So I'm going to have Matt share this code with everybody, not Kelsey 1 or 3. But this code is working a little bit differently. I put it all in one forever loop, and I could have made it all work the same, but I decided to separate things with some pause blocks, and I want you to see what you can get this code to do. All right. So Matt is going to share. Did you share that code with everybody?
I believe I did. Please
Wonderful. Let's go to gallery view. Give me a thumbs up if you just got some code from somebody. Yeah? Great. Okay. If anybody is missing that code, let us know in the chat and we can reshare it with you. But this code, if I put these side by side a little bit, I'll come here and let's investigate and see how this code is working. So Servo 3, it's staying at 35% speed. I can see it here, 35%, and here it's 35%, but you could totally change that. It can go up to 100% or down to negative 100%. That'll spin it the other way. Then it's waiting, and then position Servo 1, that's this one, is going to 130 degrees. Then it's waiting, then position Servo 2 is going to 130 degrees. There's 2, so 1, 2, and then 1, 2. So it's sort of separating those out a little bit. And you can take out some pause blocks if you wanted to, like that, or put some back in. I'll show you how I did that again. You can like move a whole line of blocks and then just bring back the ones that you want. You could also just right click on a block and you could delete some if you wanted to. But I want you to change some things in this code. Change some angles, change some percentages, change some pause blocks, get rid of some pause blocks, and let's see what happens. All right, Matt, looks like we have a couple comments coming in. What's up, man?
That's right. Actually, we had a comment here in Zoom asking if there was any way that they could do this model at home. Is there any materials that we could provide?
Oh, well, that depends. If you have a hummingbird, you can absolutely make a robot parade float at home. I recommend that you do. It will be really fun, and you will amaze all of your cats. You can chase them around the apartment. Should be fun. But we will show you some in the teacher talks section tomorrow, which I believe it's at 2 o'clock tomorrow as well. So in the webinar that focuses on teaching this, we're going to identify some materials and resources that exist on our website so that you could do this in your classroom, or if you're teaching or learning from home, so that you could do this and teach this from home as well. But basically, if you've got a hummingbird at home, you can absolutely make this. You can make the top like we are today, and after we do this section of coding, the next bit of coding we're going to do is we're going to investigate how we coded the bottom. And we're going to look at code that works, and then we're going to break it so you can see what happens when you change different things about the code. But you can absolutely make your own project like this at home if you've got a hummingbird. If you don't have a hummingbird, there are a couple different ways that you can program hummingbirds remotely. That, again, we'll talk about that more tomorrow during teacher talks, but a little bit today before we end. All right, so let me check in with our folks here on Zoom. Does anybody have some code that they want to try out? I'd love to get 2 new people to try out their code on our parade float. Raise your hand like so if you want us to put your code on our parade float. Looks like Xander and Penelope have one, and Sebastian too. All right, that's what we're going to do. We're going to share yours. Can you guys unmute yourselves so we can hear you? And tell us what you changed, Xander and Penelope and Sebastian.
I changed the speed of the merry-go-round.
Okay. Did you change anything else, like the pause blocks or the angles?
Oh, I also changed the pause blocks.
Okay. Did you make it a bigger number so it's going to wait longer, or did you make it a smaller number so it's going to move, it's going to change more quickly?
Smaller.
Okay. It should be a really active playground here. Check it out.
Oh, we have lots
You can see it's blinking right there. We're downloading it now. Oops. Here we go, Xander, Penelope, and Sebastian. Let's see what your code looks like. We just got a happy face. Whoa, look at that. So that merry-go-round, I'll show it from the top. Oh, wow, that's really, they're hopping. It's kind of got a beat to it. It's kind of nice. It's swinging really fast. He's really pumping his legs.
The swing is
He's
like
breaking out in a sweat. It's a hot day. He's really swinging.
Ooh, this is the catwalk.
I want to look at this from the top too, because that merry-go-round, you can see that it's going faster and then slower. So I want to look at your code, Xander and Penelope and Sebastian. This is the code that you shared with us. So you can see this rotation servo. You kind of have to look for the ones that are similar. Rotation servo 3 is going from 35% to 100%. That's why it's changing speeds and going slow and then fast. And then you can see that they really, here we are, that they decreased all of the pauses from 1,000 milliseconds, which is a whole second, down to just 100 milliseconds, so 1/10 of a second. So it's way shorter, so that's why everything's going so fast, so crazy. What do you think of your code, Xander and Penelope and Sebastian? Do you like it?
Yeah.
I like it too. Yeah! Show us victory arms again. Do you like your code? Show us how much you like it. Yeah! You love it. All right. All right. So let's go back to gallery view. Who else has some code that they want to put on it like this? Does anyone else have one they want to try? How about Safifa? Also, Safifa, I am so glad that you're back because I know you joined last week and it was like the wrong thing, and super glad you're here. Welcome back. Okay, so if you want to unmute yourself, we're going to share your code with us. And will you tell us what did you change? Can you talk us?
So I kind of changed the whole setup. I made it so that the swing had a wider range and didn't just go up and down. It had more, it went at like longer angles, so it took more time for it to swing back and forth. I added some pauses so that each one goes, servo 1 goes first, the swing goes first, then it pauses, and then the seesaw goes, and then finally the what do you call it? The merry-go-round.
Merry-go-round, you changed that too. And
I changed.
I have a quick question for you. I think we're having trouble finding you in Microbit Classroom.
Yeah, what name did you log into Microbit Classroom as?
I use my first name. This is just my computer. What my computer signs me in as.
And what is your first name?
Zachariah. Z-A-K-R-Y-A.
Perfect. Thank
Wonderful.
you so
And
much.
do you prefer to be called Zachariah?
Yes, please.
Okay.
Great.
Cool. Well, we will call you that then. We just knew your Zoom name was Safifa. So there we go. We're working on sharing your code with us now so we can download it. And I'm really excited to see. You added some angles for the swing here. I'm really excited to see what some of those look like. Should be cool. All right. So we shared that with ourselves. I'll go to this view here. And we're going to start to download that code. Man, I'm getting tired watching this swing, Xander. He's working so hard. These folks here, they're just, I feel like you're like making them exercise or something. There we go. It's downloading here. You can see it's blinking. Here we go, Zachariah. Okay, got a smiley face. Here's your code. Interesting. Oh, interesting. So it's going and it's stopping. We've got a little jitter of our swing here. Is that how you expected it to move? Oh, you're muted still. You want to unmute yourself?
Not exactly. I forgot to add a pause in the middle between the swing.
Let's take a look at your code. And do you want to add something in there? I think it looks like you had a pause there that was like ready to be put in there. Do you want to add a pause?
Between servo 2, where it goes from 130 to 75.
Yeah. And how long do you want that pause to be?
I'm thinking 1 second.
Okay. And then you might want to add there. I guess there's a duplicate up there. They're both going 75%, which is fine. So let's download this one and see how this looks once we add that pause in there. Man, pauses are weirdly important, right?
Sorry to interrupt you, but that's not exactly how it is on my screen. It's very different on my screen.
Okay. Well, we'll download this one and see how it looks, and then you can direct us so that it's the right thing. There we go. That gave it enough of a pause to actually for the position servo 2 to actually move now. So let's go back here. I guess Matt is going to reshare your code with us. You might have updated some things once we shared it. So we're going to reshare your code with us, and then we'll download it again. So just adding that pause allowed the, what's that called? Teeter-totter, seesaw, to move. All right, it's downloading your new code again. Okay. Let's see. It's moving.
And that
stopping.
pause wasn't in there when I initially downloaded it. I jumped the gun there. So I added that pause
we
back
added the
in.
pause back in. Okay, we're re-downloading.
Yeah.
This is something that I like about MakeCode is that like you can re-download as many times as you want. You're like, oop, I forgot something. Just re-download. It costs 5 seconds of your life to re-download, but that's a small price to pay for making weird robots. So there we go. Now that's got time to move. He's kind of jumping back here. Let's take a look at your code now. I'm interested as to why this rotation servo goes and then stops. And I think the answer is right here. It goes from 75% speed, and then it goes to 0% speed with all these, with the position servo 2, then going from 130 to 75, and 90 going, or position servo 1 going 90 to 130. With that really brief pause in there, this number, that 100, is why it jumps, why it like has like a, why it goes so fast back here. 1 second, 1 second, 100 milliseconds, so 1/10 of a second. That's why that goes so quick.
Can you scroll back to the top,
Yeah.
please?
Huh?
So it says Hummingbird rotation servo 3, 75%. Then it goes 75% again. Then it pauses. Then it goes to 0%. I haven't changed anything up there since I made it, but on my screen it goes Hummingbird rotation servo 3, 75%, pause, then rotation servo 3, 0, then pause, then rotation servo 3, -75.
Okay. Well, I'll tell you what. We'll try sharing that code with ourselves one more time and see if we can get that to work. And while we're doing that, and we're gonna re-download that code on there. I want to switch gears a little bit for our class and start to talk about the bottom of our robot. And I actually made it so that these are detachable, so that this guy can keep rocking, and we can investigate this right here. So I'm going to scooch that off to the side. We're going to investigate the bottom part. Now, normally when you make a robot parade float, you don't have to split it into 2 parts like this. We just thought it would be useful for us to kind of like talk about the construction of the parade float without the whole like parade float part, with just the moving part, so that it would be easier to literally like deconstruct in our brains. So the basic design of a rover is you've got 2 rotation servos, and you can just glue those right onto a box. Let's say a cheese nips box. Maybe we'll get a sponsorship out of this. And you can just glue them right on there. We also like to sometimes put a popsicle stick on there for stability. The thing that it's balancing on is, we like a ping pong ball, because that's nice and smooth. And so that just, when it's ready to roll, just like moves really smoothly along the ground. But these wheels, when they move, so when this wheel moves, it'll turn away from it. When this wheel moves, it'll turn away from it, like that. So these wheels moving are what controls the direction of the parade float. But then this construction right here is what I think is really cool about making it a line follower. So we've got a little bottle cap to give it some space. And then we've got an LED and a light sensor. And when we turn this on, you'll see that LED, I'm going to turn it on. You'll see that LED start to shine. It'll shine right at the camera. Protect your eyes. It's as bright as the sun. Just kidding. It's a green LED. That LED is going to go on. And then what this is going to be looking for is, it's going to be looking for whether there's a lot of light or a little bit of light coming into the sensor. So I have it pointed right at a light now. So this wheel is moving, but if I cover it up, the other wheel moves. Bright, that wheel moves. Dark, that wheel moves. So now if we take it over to the studio and check out how it works on here, it's shining a light down on the white paper. And every time it shines a lot of light back, when it's on the white paper, one wheel moves. And when it doesn't shine nearly as much light back, when it's on the black tape, the other wheel moves. So that's how it's sort of creepy crawling along this line here. That's how most line followers work. I guess that's not true. Some of them use infrared stuff. But this is how the one that we made works. That's how ours is working here. I want to check out the code for this now. All right.
Okay. And,
so, oh yeah.
And Zachariah, so I looked at your code that you had shared with us, and it still looks like it's pretty much the same. So I'm sorry if there was some discrepancies there. I can't fully explain why.
Yeah.
But I think we're going to go ahead and move forward with the line follower, if that's okay with you. I really apologize.
Okay, no problem.
Yeah.
No, I have no problem with that.
You're a cool kid. I appreciate that about you. All right. So we're going to share the line follower code now, and we're going to share this with everybody, and then we're going to investigate it and see how it works. All right. We're going to keep Zachariah's code going on here. You were the final coder of the top part, so your code stays on it. Congrats. Even though it wasn't quite what you wanted it to be, just a constant reminder. So we're going to share the line follower code with you guys, and it's actually a pretty simple code. Let's take a look at it and see what I mean. So here's our line follower code. We have the Hummingbird LED just on at 100%, and I'll zoom in just a little bit so you can see it better. There we go. Hummingbird LED is just on at 100%. And then we have this construction here, if else. So if the Hummingbird light sensor senses less than 15, and this is just a number, it goes from 0 to 100. 100% light is like if you shone your cell phone light directly at the light sensor, you could make it register 100. 0% light is covering it up all the way. So we have it being pretty dim, the threshold is pretty low. And we say if the Hummingbird light sensor senses that it's dim, then the wheel 1 is going to move and wheel 2 is not. But if it's bright, wheel 1 is not going to move and wheel 2 is. And notice we made that second one a negative number because the wheels are positioned on there such that they move opposite. So this code works. And what we thought would be fun is if you guys at home change one number in this code, and we want to see how that breaks it, or if it breaks it. So we want to just get suggestions from you guys. We'll plug it in here. We want to just get suggestions from y'all and tell us what number to change and what to change it to, and then we'll download your code and you can tell us. Arthur, it looks like you might have had a suggestion. Do you want to unmute yourself, Arthur? What one number should we change and what should we change it to? Can you hear us okay, Arthur? Got our guy moving here. All right, let me go to gallery view. Who has a suggestion for what number we should change and what we should change it to? Xander's got a suggestion. What's your suggestion, Xander? What number should we change and what should we change it to? Unmute yourself, tell us.
Negative 25 to negative 100.
Oh, okay, we're gonna do it. Let's see how it breaks. I think we've never quite done our coding lesson like this before, but let's see what happens. I don't know. It's fun to break robots, you know? And then we'll fix them with coding. Okay, looks like we're downloading. It's blinking for me there. All right. I got a happy face. I'm gonna take it over and put it in the studio. Let's see what it does. Xander, let's see how you broke it. Okay, here we go. Do you notice a difference in how it's moving? Ooh, it goes faster, that's for sure.
Yeah, I'm actually surprised it's working. It looks like it's working quite well.
It's working pretty well, Xander. You didn't break it, you just changed it. Can you describe how it's moving differently from how it was moving before?
It's moving quicker and it's bobbing to the side a little bit more.
Yeah, this wheel on this side is moving a lot faster now. So I'm gonna put it back on here. This wheel over here on the far side back there is moving a lot faster. So it really wants to turn to the left. It really likes going left. It's very excited about left. Nice. That's cool, Xander. Way to change the code in a way that didn't break it. That's cool. Let me go to gallery view. Who else has an idea? Let's put that number back where it was, Matt, so that we're keeping that consistent to what they had. And then who has a suggestion? What else should we change about this code? I'll go back here so y'all can see it. What should we change? What do you want to change, Zachariah? Is it Zachariah or Zachariah? Zachariah. What should we change, Zachariah?
I think it would be cool if we could do the opposite of what we did last time and slow the speed. So the Hummingbird rotation Servo 1, can we change it down to, I would say about 7?
7. Got it.
And the rotation Servo 2 to about maybe 12%.
Let's try it. I'll download it. We'll see how it works. This is going to be, I mean, here's the thing. Parades aren't supposed to speed by. You know, you got to look at the floats. They're not supposed to be like zoom. That's called NASCAR. That's a different thing. Okay. Did it download? Oh, it did. Let's see what happens, Zachariah. This is a fun quirk of a hummingbird. Okay, ready, set, go. Oh man, did you see that? I'm gonna put it back over here. It's moving really slow, and then it gets to the line, and it just stopped. That's because you're basically telling it how much power to give the wheel. Actually, let me stop there. Before I tell you why it's not moving, do you have any ideas? Why is it not moving at all?
I would guess because we set the servo wheel so like, you know, like at such a low percent rate, it doesn't have I believe it doesn't have like enough speed to like actually move what the object is weighing down on it. Is that
100% right? It's actually kind of heavy. and we say we're setting the speed, but we're really kind of setting the power. And we didn't give, if you set that number really low, sometimes it doesn't have enough power to even turn. It's like, you know, you on a Sunday morning when you're like, I can't get up, I don't have enough power, I need my coffee, you know, because you're a kid and you drink coffee. But so that's exactly right. That was an interesting way to break the code, to just slow it down so far that it wouldn't even move. Let's go back to gallery view. I think we've got time to try out one more. We'll switch our code back to what it was at the beginning. So I think it was 17 and -25. There we go. So we'll switch that back. And let me ask, who else has an idea? What else should we change about this code? Oops. There we go. What would you like to change about this code? Raise your hand if you have an idea. Do you have one now, Arthur? Because I know you had one early on. Can you, if you guys can hear us okay? You guys have an idea for what you want to change about this code? Or how about you, Sam? Do you have an idea? What number should we change and what should we change it to? And you don't even have to know what it'll do. You can just tell us something weird to do to this code.
I don't know, we can change everything to 100.
Change everything to 100. Let's do it. Yes. Okay. So we'll put this one. Do you want to change even that number to 100? Or do you want to change the motor speeds to 100 or the threshold of
Yeah, just the motor speeds.
Okay, we'll keep the threshold at 15. So that one's going to be 100%. That one, all of them? Wait. Do you want to do all of them, or do you want to just do the ones that we had? We need more direction. We're
all of them.
Hundreds. What do you want to do?
All of them. Just all of them.
Just all of them. All right, let's download it. You're a weird kid, Sam. I like it. Let's do it. Okay, I'm here to play catch. What do you think is going to happen, Sam, when this finishes downloading?
I don't know.
Let's find out.
Yeah, probably just gonna move very weirdly.
like it. It's not a parade, but it is a celebration. So why is it doing that, Sam? What's your explanation? Why do you think it's turning in a circle?
I don't know. Maybe it's just moving too fast to detect the changes.
It
Whatever.
definitely has something to do with it. But also, let me wait. Gotta time it. It's like catching a fish in the water. Also, if we look at the bottom here of our parade float, so that you can see the wheels spinning in different directions. I'll take the top off. Well, you're not going anywhere. You can hang out. Ooh, feel like I'm catching a toddler. So the reason that they're going in opposite directions, which is what is making it spin, I'll go to my top down here so you can see. The reason it's spinning like this is that the wheels are mounted opposite ways on the bottom of the box. So if I wanted to make it go straight and go forward, I'd need to set one motor to a positive number and the other motor to a negative number, right? Like positive and negative 100 or something like that. But if I set them both to positive, or if I set them both to negative, it does this, which is, not unfun. I think it's a good time. It's just not a line follower anymore. It's its own merry-go-round. There we go. Well, this was cool. That was a fun thing to try, Sam. I'm glad you suggested it. I can't believe it, but it's almost been an hour already, and I want to share some information with folks who are interested in joining our future classes or are interested in learning some more from BirdBrain. So if you make a robot, or if you are doing cool things at home, if you want to get inspired, you can follow us on Twitter, Instagram, and Facebook at BirdBrain Tech. We're always posting cool things from professional development we do. We're reposting teachers who are doing great things in and out of the classroom. And so we would love for you to tag us in your posts or to follow us as well. And then you can also tag the Hummingbird Kit if you use that in a project. I also really want to encourage you, if you have not been yet, to visit our website, specifically the Robotics at Home page. This page has so many great resources for you as a teacher or a parent to be able to use Hummingbird at home. There are tutorials to teach you how to use your Hummingbird and program and build with it. There are project ideas, and you can find all of our upcoming live webinars, including our teacher talk, which is tomorrow. And next week, we're going to be working with a really exciting organization to talk about, I think, what's next week? Is next week, let me go to our website really quick and find out, because I don't want to tell you the wrong thing. So if I go to birdbraintechnologies.com and I go to the at home page, that'll get me here. Here's our live classes. Next week is robot memories. So we're going to be talking about making robotics as a self-reflective practice, kind of like journaling, but instead making robots. So I'm really excited to do that one next week. You can tell because I remembered it, but I'm actually really excited. We're going to be working with the ABC Create Network and teachers there as well. And then finally, if you have any questions about anything, whether they're tech support questions or ordering questions, let's say you're doing a summer camp and you'd like us to help you advertise, or you're doing a summer camp and you're wondering if you can get bulk pricing on hummingbirds so that students can have these at home, or you'd like to bring us to your school to do some professional development. All of that you can ask us, info@birdbraintechnologies.com. You can email us there. So a big thank you to all of our folks who joined us here on Zoom today and everybody who commented live. Folks on Zoom, if you want to hang out for a couple extra minutes, if you have any other questions or comments you'd like to make, please feel free to hang out. We are going to end the live stream here. So to everybody on Facebook, thank you so much, and we will see you tomorrow for Teacher Talks. Bye.
Thank you so much for joining us today. We can't wait to see what you make on social media. On Twitter, Instagram, and Facebook, you can tag @BirdBrainTech or #HummingbirdKit, or you can even tag me. If you have any questions, be sure to email us, info@birdbraintechnologies.com. We can answer questions about purchasing, about learning, about teaching, and about professional development. If you haven't been there yet, be sure to visit our Robotics at Home page. There you can purchase a kit for yourself, learn how to use it, and even join one of our upcoming webinars. Until we see you in class, Thanks for watching from everyone at BirdBrain Technologies.